Alright, so in this video, we are going to continue the solutions to JAMB Mathematics most repeated topics. Okay, so today we are going to solve questions under set. We solve questions under binary number, binary operation rather, binary operation. We solve question under matrices and determinants. We solve question under differentiation. Differentiation. We are going to solve question under integration. We solve question under solve. Okay, and some other what now valid and important topics in what? In mathematics. Now class, what I want you to do for me is this. As at the time of recording this video, we are about getting to the 1K subscriber milestone. So kindly help us to do more by subscribing to this YouTube channel. We want to hit that 1K subscriber level. Okay, click the red subscribe button and turn on the notification bell so that you get to what now notified anytime we release amazing videos like this. So what are you waiting for? Just click the red subscribe button. Okay, like this video again so that YouTube algorithm will share this video to those that are likely to watch it. Comment in the comment section below. Okay, please make sure you help us to get to the 1K subscriber milestone. As at the time of recording this video, like I said, we are about getting to the what now? 1K subscribers milestone in YouTube. So please help us to do more. So we promise you in return amazing and comprehensive videos. Okay. So once you help us to get to the 1K subscriber levels, we are going to give you what now? More videos. So without wasting much of our time, we have these topics. Okay, we're going to solve questions under these topics. Okay, today and some things too. So I want you to watch the video today because at the end of the video, I have one special package for all of you. Okay, for those watching this video, make sure you watch the video to the end because at the end of this video, I have a special package. Some topics that will come out by God's grace. Okay, so make sure you stick around and watch the video to the end. So the first one, set theory. So we have some questions here to be solved. We are given that A and B are sets such that number of A is 8, number of B is 12, number of A and B, this symbol means what? And, intersection means and, is equal to 3. We now have to find number of A or B. Union means or, number of A or B. Now, class, we can solve questions under sets using what we call formula method. Look at the formula method. So if I want to solve question under set and I want to use formula method, look at the formula method. So I'll write formula method in set. Formula method. So if I've been asked to find number of A for two sets, number of A or B, okay, will be equal to number of A plus number of B minus number of A and B. Okay, that's the formula. Okay, number of A or B is equal to number of A plus number of B minus number of A and B if all are inclusive. Okay, if all are inclusive. But if we have exclusion, so we'll now be having number of what now? A or B, meaning if there are some students, okay, that did not participate, although they are part of the universal set, but did not take part in the what now? In the whole scenario. So this will now give us what now? Number of A plus number of B minus number of A and B, then plus number of not A and not B. Okay, so this formula is for all inclusive if all are participating. But this one is what now? With exclusion. So let us solve the first one. Given that number of A is 8 we have to find what now? Number of A and B. All of them are engaged in this. So I'll use the first formula. Are you with me? So number of A and B, number of A or B, okay, number of A or B that we have to find, number of A or B will be equals to, what's the number of A? A is 8 plus, what's the number of B? B is 12. Then minus, what's the number of A and B? Number of A and B is 3. So I'll put what here? 3 here. So this is now equals to what now? 8 plus this is 20. 20 minus 3 is what now? Is 17. So the correct answer to this is what now? 17. Okay, we can solve set question using formula method. Okay, instead of using the normal Venn diagram, you can solve question under set using formula method. And this is what I've written down here. So you can just master the formula. In JAMB, we need to do pen. We don't waste time in JAMB. So this will help us very well in what now? In JAMB. So let us go to the second question. In a class of 46 students, that is the universal set. Okay, I can call this number of A or B as the universal set. Take note of that. Number of A and B can be the what? The universal set. So I can say number of the universal set now, which for everything is equal to what now? Number of A plus number of B minus number of what now? A and what? A and B. This universal set is A or B. Okay? This one here, universal set is A or B. So get the first question out of the way. So let's go to the second question. Second question. So we have in a class of 46 students. So it means our number of universal set is equals to what now? 46. 22 play football. Number of those that play football is 22. Number of those that plays football is 22. 26 play volleyball. Number of volleyball is 26. If 3 students play both games, number of football and volleyball is 3. What are we to find? How many play neither? So we have to find number of P intersection, F intersection, F prime intersection what now? V what? V prime. We don't know this one. Let us assume this is what? Is X. So it means in this case, we have exclusion. Where is the exclusion? This is the exclusion. So our formula now reads number of the universal set will be equals to what now? Using formula method, number of F plus number of V minus number of F and V, then plus number of F prime intersection what now? V prime. So let us substitute. What's our universal set? That is 46. So we have 46 is equals to number of F is 22. So we have 22 here plus number of V is 26 minus number of F and B is 3. Then plus number of not F and not V is what? Is X. And that's what we are asked to find. So we have 46 is equals to 22 plus this will give us what now? 48. 48 minus this will give us 45. Then we have plus what? Plus X. 22 plus 26 is 48. 48 minus 3 is what now? 45. So our X will be equals to, correct like terms, 46 minus what now? 45. And that will give us what now? 1. So the correct answer to this word is 1. Formula method. Formula method. So please make sure you what now? You stick to the formula method. Given that for set A and B in a universal set E, A is a subset. This is symbol for subset. Now, class, what is subset? A subset is a set that is found in another set. Let me quickly explain this before I answer that question. Okay? If they say A is a subset of what? Of B, now, 2 conditions is attached to this. For A to be a subset of B, 2 conditions is attached to this. The first one is A has elements less than B. That's the first condition. The elements of A are less than what now? Element in what? In B. or A has equal elements as B. So those are the two conditions that must be satisfied before A can be a subset of B. For example, if I have B to be equals to 1, 2, 3, and 4, and I have A to be equals to 2 and 3. In this case, A is a subset of B. What is the meaning? A has what now? Element that are less than element of B. Because 2 is here, 2 is here, 3 is here, 3 is here. So it means B is more than elements in B, set B is more than elements in what now? Set A. That's the first condition. A has element less than B. Or I can have something like this. If B is 2, 3, 4, and A equals 2, 3, 4. This is the second condition under subset. So here, A is a subset of what now? Of B, meaning A has equal elements as B. So for something to be a subset, for a set to be a subset of another set, it means the first set must have a lesser element compared to the second set, or have what now? Equal element. That is the two conditions that must be satisfied before something can be a subset of something. Okay, so look at this. We are asked to find A intersection. Okay, fine. We are asked to find let me wipe this one off. Let me wipe this place off. We are now required to find A intersection B prime. Then mind you, class, A is a subset of B. So what is now A intersection B? Let us use this as case study. So what will be A intersection B from here? A intersection B, class, A intersection B, from what I've written here, will be 2 and 3, isn't it? Will be 2 and 3. Will be 2 and 3. And this 2 and 3 is the same thing as saying what now? A. So it means if A is a subset of B, then A intersection B will give us what now? Will give us what? A. Is it clear? It will give us A. So it means if I analyze this one, I will have A intersection A complement, because this one here has changed to what now? A. Are you with me? Then I have the prime here, which is the complement. Now, what is A intersection A complement, class? For there to be a complement is a function of the universal set. Complement is a function of the universal set. It means what I have in that set, okay, what I have in that set, that the universal set has more of it. Let me reframe. What is contained in the universal set but not in that set? That's what we call subset. For example, look at this. Let me assume I have my universal set as U, okay, which is set of 1, 2, 3, 4, and 5. Okay, and I have my A as 2, 3, and 4. So what will now be A prime? A prime or A complement means element in this universal set that is not in this A. So what are the elements? The elements will be equal to what now? 1 and 5. 1 and 5. If they now ask us that, what is A intersection A prime? Look at this. So universal set is this. A is this. A prime is this. What is now A intersection A prime? As in, what can you see inside A? And that thing, you can also see it inside A complement. They have anything in common? They don't. So here, our answer will be the empty what now? Since they don't have anything in common, to be empty. So our answer here will be equals to what now? Empty set. So the correct answer is what? Is B. But here, they use E as universal set. We can use this symbol for universal set. So this is just the analysis. So A prime, A intersection A prime give us what now? Give us empty set. So that is the answer to that what question. So let us go to another question. Let us go to another question. How many subsets will a set containing 5 elements have? How many subsets will a set containing 5 elements have? how many subsets will a set containing 5 elements have? So say how many subsets will a set containing 5 elements have? Now, number of subset is called power set. Okay, class. Number of subset is called power set because we have to find how many subsets. So power set is equals to what now? Number of subset. Okay, and that's the formula. What's the formula? 2 raised to the power of what? N. That's the formula for power set. And what is n? N is the number of what now? Of elements. N is the number of what now? Elements. So how many elements does this set have? It has 5 elements. So our n here is what now? Is 5. Let me give you the options. 25, 32, 36, 64. 25, 32, 36, 60 what now? 4. This is option A, option B, option C, and option what now? D. So power set, this is the formula for power set. N is the number of elements. Then this question, this set has 5 elements. But now to find how many subsets, then number of subsets is called power set. Are you with me? So that will now be equals to what now? 2 raised to power, our n is what? Our n is 5. That will be 2 raised to power what now? 5. And what is 2 raised to power 5? That will be equals to what now? 32. 2 raised to power 5 means 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2. That will give us 32. So the correct answer is what now? Is 32. Let us solve more questions. Still on the set. Now look at this. Look at this. Let me write this one up. Power set exists in set. Power set exists in set. And we can use formula method too to solve question on the set. Look at this. Which of the following is equivalent to, look at this. We have to find, we are given P prime intersection Q union Q prime. Okay, and everything now all prime. Everything all prime. And this one is in bracket. So we have options A, P, option B, we have P prime, option C, we have Q, option D, we have Q prime. Now, let's say which of the following is equivalent to what you have here? Class, look at this. I will use analysis to solve this question. Okay? It's very simple, but you have to be very careful. You have to be very, very careful. So look at what I'm going to do. I told you before I can have complement will be a function of universal set. So I must have gotten universal set first ready before we discuss what now? Complement. So let me suppose I want to do this one inside here. Suppose I have universal set U containing elements 1, 2, so I won't go far, 1, 2, 3, and 4. And I have my Q containing elements 2 and 4. Class, first thing is, what is Q prime? Q prime will be elements in this universal set, but not in Q, which will be element what now? 1 and what now? And 3. Okay? So what is now Q? Q union Q complement. What that will give us? Q union Q complement means what now? Everything that is found in what now? Q and Q what now? Complement or Q prime. And that will give us element what now? 1, 2, 3, and 4. So it means Q union Q prime is universal set. Are you with me? Q union Q prime is what now? Universal what now? Set. Look at this. 1, 2, 3, 4. 1, 2, 3, 4. So it means here I will have what now? P prime. Break it down. P prime intersection Q union Q prime will give us what now? Universal set. So I have universal set. Okay, like this. So I've solved this one here. Then everything all what now? All prime. Okay. Now, prime as used in this case means opposite. This is prime. So I will now use this prime to open this bracket. Are you with me? I will now be having prime, P prime prime, making 2. I will prime intersection. I will prime what now? Universal set. I've used this one to open this bracket. P prime prime means, suppose this one is negative, what an opposite. So if I should prime universal set, I will have what now? Empty set. If I prime intersection, I will have union. Meaning, what is the opposite of intersection? It is union. What is the opposite of what now? Universal set is empty set. Okay, opposite of everything is nothing. Universal set is everything. Opposite of everything is what now? Is nothing. So here, this one will become union. Opposite of intersection is what? Is union. Opposite of universal set is what now? Is empty what now? Is empty set. Now, P prime prime means minus times minus, which give us what now? Plus. So minus times minus will be what now? Will be P. Are you with me? Now look at this. P prime prime means P prime prime is P. I will take this one as what now? As negative. Negative times negative equals what now? Positive. Now look at this. P union empty set. P union empty set. What will be P union empty set? That will give us P. That will give us P. As simple as that. P union empty set. Suppose P is this. Look at this. P is 2, 4, 6. And I have empty set again. Suppose I have B to be an empty set. So what is P union B? That will be what now? 2, 4, 6. Okay? Since nothing is here, it will give us what now? Our P back. So P union empty set is P. So correct answer here is what? Is P. More questions? More questions. So I won't waste much time here. More question? More question. I hope this is clear. So just revisit the video, pause anything that you want to pause and get what I've explained here. Things are happening on insert. Things are happening in set. More than the one that we were taught in school. Okay? So please, if you've learned something so far in this video, please kindly subscribe. Like I told you earlier, okay, we are about to reach the 1K subscriber milestone. Please, I want you all to help us to do more. Okay, just subscribe and give this video thumbs up. Okay, so our YouTube algorithm will carry the video to those that want to see it. Please give it thumbs up. That thing that you see that icon like this, just press it like this. Okay, give the video thumbs up. If you enjoyed this video so far, give it thumbs up and subscribe, and make sure you comment. That comment box, okay, comments there. All these things will make YouTube to what now? To get this video to those that want to see it. And many students want to see this video. If you don't give it thumbs up, if you don't subscribe and you don't comment, it won't go far. Please help us to do more. We want to reach the 1K subscriber level. Please subscribe to this YouTube channel, share the video, comment and like. And as you do so, God will bless you. You will pass your exam by God's grace. This is our year. Nothing will work now. Nothing will change that. And if you have any question to ask, you can call any of the number that you see on the screen. God bless you. So back to the what? Back to our video. So I say P is what? P is giving us 1, 2, 3, 4, 5, 6, 7, what? 7, 8. And our Q is giving us 1, 4, 7. 1, 4, 7. Then we now have R. R is giving us 2, 4, 8. We are now asked to find P intersection Q. Then your answer, union R. Okay? P intersection Q, union R. So what's the first thing? I will solve this one first. What is the meaning of intersection? This symbol. It means and. What is common between P and Q? What I can see in P, I can also see it in what now? In Q. That is the meaning of this symbol, intersection. It is common. Okay, let us use that word. Common to P and Q. So what is common to P and Q? I have one here. So it means P and Q will give us elements. One is here, I write 1 down, comma. Another thing, 4 is here, I write 4 down, comma. 7 is here, I write 7 down. Okay? So these are P and Q. Then union R. What's our R? Our R is what? Our R is 2, 4, 8. What's the meaning of union? Union means all. Everything inside these two sets is meaning of what now? Union. Intersection means what is common between the two sets, but union means everything in the two sets without repetition. So we have this and this now will now be 1 is here, you can see 1, you can see 2, I can see 4. I will not do repetition. 4 is here, 4 is here, I'll pick 1. I can see what again? I can see 7. I can see what now? 8. So that is the answer to that question. So the answer is 1, 2, 4, 7, 8. Option C. Option C is the answer. Let us do question under Venn diagram. Let us solve question under Venn diagram. Okay? Okay, so we can be giving yes, we can be giving question under Venn diagram. We can be giving question under Venn diagram. So let me write this one up. So I've treated union, I've treated complement, I've treated what now? Intersection. Okay, that is that. So look at this, look at this, look at this, look at this. Look at this. This is the Venn diagram. It is three Venn diagram. I want to use this one to explain many things here. Please, before I solve the question, this is volleyball. This is hockey. This is hockey. And this is swimming. This is 7. This is 8. This is 6. This is 2. This is 4. This is 3. And this is what now? 10. John says the Venn diagram shows a class of 50 students. It means our universal set is 50. All of them, universal set, all is 50. All of them is 50. What we have to find? With the games they play, how many students play only 2 games? Only 2 games. So how many students play only 2 games? Only 2 games. Now, class, set is very interesting, very interesting. Let me do the analysis first so you understand what I'm trying to say here. Now, everything here, this circle, everything here is for volleyball. So if I have to find number of volleyball, I will add everything here. 7 plus 8, 15. 15 plus this 2, that will be 17. 17 plus 4, that will be 21. So number of volleyball is 21. Are you with me? Now, number of hockey is everything here. Number of hockey is everything here. So what will be hockey? 6 plus 8 plus 2 plus 3. That is for what now? For hockey. If they now say hockey only, 6 is hockey only. Hockey is everything here. 6 plus this, which is 14. 14 plus this, which is what now? 16. 6 plus this is what now? 19, I suppose. 16, yeah, that's 19. This is 10, that is 19. So hockey is 19. Hockey is 19. Number of hockey is 19. But hockey only is 6. So volleyball only is everything here that we've done earlier. If I say volleyball only is 7. Volleyball is everything here. This circle. Volleyball only is 7. Swimming only is 10. Then if they say number of swimming, that will be 10 plus 4 plus 2 plus 3. This is 5, this is 9. This is also what now? 19. Swimming is 19. Swimming only is what now? Is 10. If they now say volleyball and hockey will be 8 plus 2. Volleyball and hockey is 8 plus 2. But if it's volleyball and hockey only, it is 8. Because look at this. Under 2 Venn diagram analysis, if I have something like this, if this one is what now? Is 4. Okay, let me put 2 here. I put 2 here. I put 5 here. And I put what now? 3 here. This one is what? A. This one is what now? Is B. What is A? A is 2 plus 5, which is 7. What is A only? A only is 5. What is B? B is 2 plus 3, which is what now? 5. What is B only? B only is what now? Is 3. What is A and B? A and B is 2. This thing. This is A and B. A and B is this. A and B is 2. So where is volleyball and hockey? So if I put volleyball here, if I put hockey here, this place is what now? Is 7? No, it can't be 7. Okay, I want to get the inner part. Everything here is what? 7, 8, 2 and what now? Are you with me? 7, 8, 2 and everything for hockey. Then but the inner part is what now? 8 and 2. You check it very well. This part for volleyball and hockey is 8 and 2. So it means volleyball and hockey will be what now? 8 plus 2. Are you with me? But if you say volleyball and hockey only, this place will be off. So volleyball and hockey only will be equals to what now? 8. Volleyball and hockey only will be equals to what now? 8. Okay, but let us go to what they say we should find. So you find only 2 games only. So it means either volleyball and hockey only, or volleyball and swimming only, or hockey and swimming only. So this is 2 games, only 2 games only. So 8 will be there, or volleyball and swimming only, or hockey and swimming only. The options that we have there, we have options 15, 16, 20 and 18. 15, 16, 20 and what now? 18. This is option A, B, option C, and option what now? D. So what is only 2 games? That will be 8 plus this 11, or 12 rather. 8 plus 4 is 12. 12 plus this is what now? Is 15. It's 15. So 4 plus this 7, that is 15. So the correct answer is what now? Is 15. Is 15. So please, are you with me? I think I've done some explanations here. If they say hockey only 6, volleyball only 7, swimming only, you see it? It's 10. Hockey and swimming only 3. Hockey and swimming 5. Hockey and volleyball only 8. Hockey and volleyball 10. 8 plus 2, 10. Volleyball and swimming only 4. Volleyball and swimming 4 plus 2 equals what now? 6. Volleyball and hockey and swimming, it is 2. Okay? Volleyball and hockey and swimming. So we have volleyball, that is hockey, and swimming is what now? 2. When they say volleyball or hockey or swimming, okay? So we are going to add everything. 7 plus 6 plus 10 plus 4 plus 8 plus 3 plus 2. That is volleyball or hockey or swimming. Everything. That is the universal set. And if you add everything, you're going to have what now? 50. Must have 50. If you add everything. That is all. Or always what now? Everything. So like I've said earlier. So look at this question. Still under Venn diagram. I think this will be the last question on that set. So we can move to another thing entirely, which is binary what now? Binary number. So binary number. So I'll wipe this one off. So look at this. We are given 3 Venn diagram 2. We are given this. We are given this. We are given this. And this place was shaded. I think I've just explained. Yeah, they put X here, they put Y here, they put Z here. That said, the shaded region in the Venn diagram is option A, give us X and Z. Option B, give us X complement, intersection Y, intersection Z. Option C, give us X and Y, complement, intersection what now? Z. Then D, give us X and Y, intersection what now? Z complement. So what's the answer? This place is what now? X and Z. I've just explained that. X and Z only. X and Z only. X and Z only. So this is this. This one is X and Z though. Don't go and mix this one up. This is X and Z only. Because we're going to prime Y to become only. We'll prime the third one. This one is X and Z. X and Z is everything here. Everything here is X and Z. Everything here is X and Z. This is what now? X and Z only. I think I've explained that. X and Z only. So this one is X and Z. This one is what now? Y and Z only, because they primed what? They primed what now? S. This one is X and Y only. What's the prime what now? So enough of question on that set. You can solve more questions. That's just the basis. That's the basis. So let us go. Next topic is what we call binary operation. Binary operation. Let me just quickly introduce us to what we call binary operation. Under that, you see something like this. They'll say S, maybe S operation Y is equals to what? S plus Y plus 2xy. Okay? That says find one operation what now? One operation 2. This thing means what now? Binary operation. This thing, it is what we use to combine X and Y. Now, what are we going to do? Since this sign and this sign, they are the same thing. Are you with me? It means our X is 1, our Y is 2. Anywhere we see X, we put 1. Anywhere we see Y, we put 2. That's all. If the signs are the same. Okay? If the signs are the same. So it means our X is 1 here, plus, what is Y? Our Y is 2, plus 2 times, what is X? 1, times, what is Y? 2. Are you with me? This will now be 1 plus 2 plus 2 times 1, 2. 2 times 2, we have what now? 4. This will now be what? 1 plus 2 is 3. 3 plus 4 is what now? Is 7. That is what we have under binary operation. It's as simple as that. But let us solve JAMB question. Let's solve JAMB question. So look at this. That says a binary operation, they cannot give you a hand. So please don't be disturbed though. A binary operation, they can write it in words like this. A binary operation, this is symbol I want to use. On real numbers is defined. They will give you the rule I want to use to combine them. Is defined by, for every A combined with B, you must have 2AB plus A. 2AB plus A. We now have to find 2 operation 3. Options A, 14. Option B, 13. Option C, 12. Option D, 9. So what are we going to do? So the same format. What's our A? Our A is 2. Our B is 3. That's all. Anywhere you see A, you put 2. Anywhere you see B, because the rule, this sign, they're the same thing. Look at what I'm saying. I have A option B is equals to what now? 2AB plus A. So what's now 2 operation 3? The same symbol. So our A is 2 and our B is what now? 3. So we have 2 times 2 times 2A means 2 times A times B. Our B is 3 here. So we have 3. Then plus our A is 2, we have 2. So what do we have here? 2 times 2, 4. 4 times 3, 12. 12 plus 2. And what is 12 plus 2? That will give us what now? 14. So the answer to this question is 14. Okay? Binary operation. Binary operation. The first one we did was number base. You can call it number base. The first video. Make sure you watch the first video, please. I will put the link of the first video down the comment section below. The link to the first video. Make sure you watch the two. We've done some parts, solve some questions in the first video. Very interesting video. Make sure you watch it. Then another question here. A binary operation, this is defined. Let me just change it. A binary operation, this is defined on the set of integers such that this one is now having P. Say binary operation, this is defined on set of integers. The same thing. Set of integers on set of integers on set of integers. Integers is defined. A binary operation, this on set of integers is defined by P operation Q. P operation Q is equals to PQ plus P minus Q. PQ means P times Q plus P minus Q. So look at what we have to find. Look at what we are asked to find. We're now asked to find 2 operation 3 operation 4. Same in first. We solve the bracket first. What are your options? 11, 13. 11 is here. 13 is here. 15 is here. 22 is here. It's the same concept. What are you going to do? We solve the innermost one first, which is the bracket. Which is the bracket. What is the rule? Let me write the rule down. What is the rule of combination? What is the rule of combination? The rule says for every P upon Q, okay, I must have what now? PQ plus P minus what now? Let me write it down so you'll be able to see it very well. P upon Q must give me what? PQ plus P minus Q. So what is now 3 upon 4? 3 upon 4. What's our P? P is 3. Our Q is 4. So we have 3 times 4. Then plus P is 3 minus what now? 4, which is Q. So this will be 12 plus 3 minus what? 4. This will now be what now? 15. This is 11. So it means this place is 2 operation. This one is now what now? 11. I will now solve this one again. Because I've done this one to give us what now? 11. So I will now solve this one again using the same what now? Rule of combination. So I'm having P operation Q is still what now? PQ plus P minus what? Minus Q. So in this place now, we'll now be looking for what now? 2 operation 11. Because 3 operation 4 give us 11. Are you with me? So anywhere we see P, we put 2. Anywhere we see Q, we put what now? 11. This will now be 2 times 11 plus our P is 2 minus what now? Minus 11. 2 times 11 is what now? 22 plus 2 minus what? 11. 22 minus 11 is 11. 11 plus 2 is 13. So answer to this question is 13, not 11, it's 13. Option what now? Option B. Okay? That's the binary operation for you. Let's just solve 2 more questions. The one that has to do with what now? Identity and inverse. They can ask us identity and inverse under binary. Okay, look at this one too. 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 So I will not miss it. I have many questions, but I just want to give you the concept. With this, at God's will, you're going to make it. At God's will, you're going to make it. Said if x operation y is equals to x plus y minus 3xy minus 3xy. What is the value of x? We'll have to find x. Find x if x operation 2 is minus 13. X operation 3 is minus 13. Let us solve this question. What is the rule of combination? For every x operation y, I must add what? X plus y minus 3xy. What is x operation 2 first? X operation 2 means our x is still x. Our y is now 2. So anywhere we see x, we still put x plus. Anywhere we now see y, we put 2 minus. This is 3 times x times what now? 2. What do I have here? X plus 2 minus 6x. Because 3 times this is 6, then times x is 6x. So we have x minus 6x. That is what now? Minus 5x. So I'm having 2 minus 5x. Here now says your x operation 2 is minus 13. And what is x operation 2? 2 minus 5 what? 5x. So it means therefore our 2 minus 5x, let me write it. X operation 2 is equals to what now? Minus 13. It was given. So what is this? 2 minus 5x is equals to minus 13. So what's the next thing? We can correct the items down. This one can go here to become plus. It can come here to become what now? Plus. So I'm having 2 plus 13 is equals to what now? 5x. This will now be what now? 15 is equals to what now? 5x. Divide by side by what? By 5. By 5. This will cancel out this. So this will be what? Here 1. So our x is equals to what now? 3. So the question can be in this format too. Okay, after you've gotten your answer, the now say is equals to something. Let us quickly go to identity element and what now? And inverse under binary operation. Identity element and what? And inverse under binary operation. So look at this. What is identity and what is inverse? What is identity and what is inverse? Identity element identity element. Identity element. Use symbol E for it. Symbol E. Then I will write what now? Inverse of an element. Inverse of an element. Alright, so now what do you mean of identity? Identity is what you combine with something. Anytime I combine identity with something, it will give us that thing back. Anytime I combine identity with anything, I must add that thing back. Are you getting me? So if I say 2 plus 0, how give us what now? 2. It means in this case, 0 is what now? Identity. Why? Because when I combine 0 with 2, I have 2 back. Identity is what you combine with something to add that thing back. So if I say 2 times 1, it give us what now? 2. So here, 1 is also what now? Identity element. But here, it was being added. So we call it additive identity. Here, it was being multiplied. We call it what now? Multiplicative identity. So 0 is additive identity. 1 is multiplicative what now? And in this example, 1 is multiplicative what now? Identity. What is identity? Identity is what you combine with something to add that thing back. And what is inverse? Inverse is what you combine with an element to have what now? Identity. So this is inverse. Inverse means what? Raised to power minus 1 or 1 over x. So whenever I combine inverse of an element with that element must be combined with its inverse. So if I have 2 here, it will be combined with 2 inverse. If I have 10 here, it will be combined with what now? 10 inverse. I must combine the inverse of that element with its element to have what now? Identity. Are you with me? So what is that? Under inverse and what? And for example, look at this. If I have s option y, it's going to what now? S plus y plus xy. But I have to find the identity element. So find the identity element. Find first one. Identity element. Identity element. The second one. Inverse of x. Inverse of x. So let me quickly solve this. I won't wipe this one off because identity element, I need it. Inverse. These are the expressions to that. So I have s plus y. S plus y equals to what now? S combined with y rather. S plus y plus what now? Xy. So what do I have here? I will not change what now? I can change anyone to identity. I can change anyone to identity. Anyone. I can change s, I can change y. So it means here, I've changed this y to, I want to get identity. I've changed y to what now? To e. So anywhere I see y, it becomes what now? E. S is what now? X. So I have what here? X plus. This one becomes what now? E. But what now? X times y, which is what now? S times z, se. Whenever you combine an element with identity, what will it give you? It gives us that element back. So s combined with identity will give us what now? X is equals to s plus e plus what now? Se. I'll bring this one here, collect items. I'll be having s minus x is equals to e plus se. I'm looking for e. I can factor e out. We left it what now? 1 plus what here? 1 plus s. So s minus x is what now? Is 0. So what's the next thing? I will divide by what? 1 plus x all over 1 plus x. This will cancel out this. So our e will be equal to what now? 0 over anything will give us what now? 0. So our identity element is what? Is 0. I can equally change this one to what now? To e. So I will have e combined with what? With y. And you get to look at this. Since this I should find identity, I can change any of the elements. I can use this one too. I can say, okay, I want e to be the identity element. I'll change s to what? To e. Combine with what? With y. Must give us. So it means anywhere we see s now, it becomes what now? E. Then plus what? Plus y. Plus what now? ye. Or ey. Anyhow. Okay? So here I change y to e. Let us see whether we're going to have the same result. But in this case, I want to change s to e. So whenever I combine identity combined with what? With y will give us what now? Y. When you combine identity with anything, give us what now? That thing back. So this one is what now? E plus y plus what now? Ye. Y will come here. I have y minus y. Because what? E plus what now? Ye. So I'll factor e out. 1 plus y. 1 plus y. So this is 0. It's the same thing. over 1 plus y over 1 plus y. So this will cancel out this, our figures up now is 0. So anyone that you want to change, you're going to have the same what now, the same effect, the same result. So that is that how to solve question under what now? Under identity. Then inverse. Inverse. Inverse means we have to find inverse of x. And so I have to change y to what now? Inverse of x. We have to find inverse of, if they say inverse of y, I will change this what? This 1 to what? Inverse of y. Because I said inverse must combine with that element. Inverse of an element must combine with the element. So let us go here. Let us go. So here, I now have s combined with its inverse. So it means anywhere we see s, we still put x. So s is still here. Plus, anywhere we see y now, it becomes what now? X inverse. So I have x inverse. Then plus x times y. That is x times what now? X inverse. And I'm looking for what now? X inverse. That is inverse of x. Anytime I combine an element with its inverse, what will I have? I will have identity. But the identity is what? Is 0. Anytime I combine an element with its inverse, I must have what now? I must have identity. So before I get inverse, I must know identity element first. But here, we've solved that. Identity is what now? Is 0. So here, we now have what now? 0. Just what now? S plus x inverse plus x inverse. Or correct like terms, I have 0 minus x is equals to x inverse plus x inverse. So what do I have here? I'll factor x inverse out. X inverse, we have what? 1 plus what now? Plus x. X inverse times 1, x inverse. X inverse times plus x inverse. Okay? Because what now? Minus x. So what's the next thing? I will divide both sides by what now? 1 plus x. So all over 1 plus x, all over 1 plus x. This becomes out this. So it means our x inverse is equals to what now? Minus x all over 1 plus x. Okay? Are you with me? So for inverse not to exist, if they say for inverse not to exist, I will equate this one to what now? To 0. So it means 1 plus x equals to what now? 0. So x will be equals to what now? Minus 1. For inverse not to exist. So if I should put minus 1 here, everything will be what now? Undefined. But this will be 0. 1 minus 1 is what? Is 0. So anything by 0 is what now? Undefined. So for inverse, if they say what value of x does the inverse not exist, x will be what? Minus 1. How will I do that? I will take the denominator only. I will equate it to what now? To 0. And I'll get the value of what? Of x. It's as simple as that. So let us solve a question. Just one question. So we're now going to what now? Matrix. Matrix. Go to matrix. Go to matrix. So let's solve one question. Yeah, I just did the explanation. So let's solve one question. Let's solve one question. It said a binary operation on the set of real numbers is defined by, let's say it's defined by what now? M by, I think you know by what's what I mean now. M by n is what? Mn all over what now? All over 2. For all m comma n is an element of R. Don't forget to this one just they want to make this thing to look what now convincing to us. Don't mind them, all these ones. Although it has meaning. M and n are element of what now? Real numbers, but this is what we need. This is the cocoa. This is what we need. What I have to find? If the identity element is 2, so they can give us what? Identity element as 2. Identity element as 2. Now I tell you that before you can get inverse, you must have what now? Identity. But in the case of they've given us identity element as 2. That's why you find the inverse of minus 5. Find inverse of minus 5. Okay, what are the options? We have A minus 4 over 5, B minus 4 over 5, C 4 over 5, then D we have 5. So let us go. Before you can solve inverse, you must know what now? Identity. Before you can solve inverse, you must know identity. So what do you have here? So I'm looking for what now? Inverse of what? Of 5. So it means I must combine inverse of 5. Listen. I must combine some with what? With this. minus 5 combined with its inverse. Are you with me? So I'll have this one will change to minus 5. Okay, combined with its inverse. And that inverse is what? Inverse of minus 5. And that we're having minus 5. This is the inverse of minus 5. Are you with me? But you can get inverse of an element, you must combine the inverse of that element with what now? With that element. Okay? So it means I'll change it to what now? Minus 5 first. I'll change to minus 5. Then this one will change to what now? The inverse of minus 5 I'm looking for. So it means anywhere I see what now? Anywhere I see m, it will be minus 5. So I'm having minus 5 times anywhere I see n, it will be what now? Minus 5 inverse. Okay? So all over what now? All over 2. I hope this is clear. If I want to get inverse of an element, I must combine the inverse of that element with the element. So here they say we should find the inverse of minus 5. So it means I'll first change this one to what now? Minus 5. If they say find the inverse of 2, I'll first change this one to what now? To 2. So I'll now become what now? 2 raised to power what now? Minus 1. Meaning I have 2 combined with its inverse. This is the inverse of 2. But here, the element is what now? Minus 5. Okay? So minus 5 combined with its inverse. Are you with me? So anywhere I see m, minus 5, anywhere I see what? And anytime I combine an element with its inverse, what we have, I must have what now? Identity element, from what I explained. And what's the identity element given? It's given as 2. It means everything here goes to what now? 2. Because I'm combining an element with its inverse. It must give me what now? Identity. It goes to what? Minus 5 multiplied by rather minus 5 what now? Inverse. What about what now? What about 2? What's the next thing now? Cross multiply. This will be 2 times 2, which is 4, minus 5 times minus 5 what? Inverse. This is what I'm looking for. Minus 5 inverse. So what will I do? I will divide by what now? Minus 5. By minus 5. By minus 5. So this will cancel out this. So minus 5 inverse will be equals to what now? Minus 4 all over what? All over 5. Option what? Option A. If I don't want to compound this thing, okay? Let me just say let minus 5 inverse or inverse of minus 5. Inverse of minus 5, inverse of minus 5 be maybe x. So this one will change to what now? X. Are you with me? So change to x. So I'm looking for the inverse, which is what? X. So that you don't get confused. This one should be what now? X. Is that not? This should be what now? X. Let me use y. Because of this symbol here, let me use y. So let it be y. Let it be y. Let it be y. Be y. So this will now be what now? Y. This is what I'm looking for. So this will now be. You see it? I think it is clearer now. So now, so what we have here now? 4. That's what? Minus 5 what? Minus 5 y. So y minus 5. Y minus 5. And that will cancel out minus 5. Y will be equals to what now? Minus 4 by what now? 5. And y is what? Inverse of what? Minus 5. So we can solve it like this. So it will look very well. I think this one looks simpler than the first one I did. So you get confused. Okay? So I understand what I did, but let me make the thing to look simpler. That's the reason why I'm here. I must make sure that the solution is what? Is very simple. So everybody can get the working. So anytime we have to find inverse, let's just use alphabet for it. So I won't get confused. So let the inverse be y. So minus 5 is the inverse. Okay? Is this. So that is that under what? Under binary operation. Then lastly on this, it can be in tabular form. They can give you in tabular form. They can give you in tabular form. Are you with me? You can just say something like this. Maybe you put KLM. Okay? You now put KLM here too. KLM. So here you put KLM. Then they will put K L M. So I'm having K here, L M. Good. K L M. KLM. So here I'm having M, I'm having L, here I'm having K, I'm having M. So the answer to find the good. Please subscribe to our YouTube channel, please. Oh, if you're enjoying the video so far, don't forget to subscribe. What are you waiting for? Please subscribe to our YouTube channel. Just subscribe. Okay, let us hit that 1K subscribers milestone. We are about getting to 1K subscriber milestone on YouTube. So just click and share the video. Okay, click, give the video thumbs up. That symbol like this, just press it, thumbs up. Okay, and comment in the video in the comment box below that okay, this video is this. Let us know what is happening. If you really enjoy the video, so let us know if we are interacting with people. That's the reason. That's just the basic of this thing. So if we give out videos, okay, it's from you, our subscribers, our audience, that will know that okay, this video is what? It is okay. So what are the areas that we are going to improve? That's the reason why we have to interact. Please give this video thumbs up. Click it so that YouTube will carry it to more people that will see it. The algorithm will carry it. So comment, let us interact. Comment. Okay, subscribe too. We want to reach one. As at time of recording this video, we are close to achieving what now? 1,000 subscribers. And with your help us to do more. Help us to do more. So when we reach 1,000K subscribers, we will produce more videos. More amazing content will come out. This is just the beginning. This is just the beginning. You don't see anything. It's just the beginning. So we want to produce more content, more videos, solid, comprehensive, amazing videos. If you permit me to use that word, okay? Because videos are coming, things are happening. I want to produce videos, so we want you to help us. So I'll be able to work now. It's going to be a symbiotic relationship. You will gain and will equally gain. So please click the red subscribe button, subscribe, share the link of the videos, okay? Share the link to people writing what now? Mass JAMB. Although white students you can gain from it. White students you can gain from it. Those writing YN, share it to them. Those writing JAMB, share it to them. Okay, and comment, subscribe, comment. Okay, and if you have anything to discuss with us, you can call any of the number okay on the screen. Please, we need you to help us to reach that 1,000 subscriber milestone on YouTube, which is very possible if you can do it for us. Help us to do more. We want to produce videos anyway. So that's our passion. Producing quality videos is our passion. That's what we do. Now look at this. Here we have to find what? Identity element. Identity element. Identity element. And inverse. Inverse of, let's say inverse of K. So that's the two things we have to find. It could be in tabular form. If it's in tabular forms, don't disturb yourself. Now then we have KLM. Are you with me? KLM. Just go inside the table, either vertically or horizontally. Where you have this arrangement, this is KLM vertically. I will go inside the table. The way I have this KLM, make I have it like that too. Yeah, this is this place. KLM. See it? What's on top is our identity. Yeah, simple as that. That's the shortcut. I have KLM. Enter the table again. Where do I have KLM? KLM. What's on top? Is identity. So I will say identity element. Identity element is what? Is K. Sorry, is M. What is the meaning of identity? From our definition, what you combine with something to have that thing. What you combine with something to have that thing back is identity element. So if I combine K combined with M, I will have K. You see it? L combined with M, I will have L. M combined with M, I will have M. And this is what you combine with something to have that thing back. So anytime I combine K with M, I will have K back. Anytime I combine L with M, I will have L back. Anytime I combine M with M, I will have M back. Either you do it vertically or what? Horizontally. See, KLM. Horizontally, KLM. What is on top is what now? Is identity. Either you pick vertical arrangement or you pick horizontal arrangement. For the vertical, KLM. Enter the table. KLM. On top, identity. For horizontal, KLM. Enter the table. KLM. On top is what now? Identity. So now we should find the inverse of what? Inverse of K. It means what will I combine with K? What will I combine? That's nothing is what? It's 6. To have what now? To have identity element. to have identity element, which is E, and our E is what now? Is M. What will I combine with K to have M? We said inverse is what you combine with something to have identity element. So what will I combine with K to have M? Let us go. What will I combine with K to have M? K combined with L will give us M. You see it? K combined with KL, K combined with L, M, K combined with M, K. But what will I combine with K to give M? Whenever I combine K combined with L, give us what now? M. So whenever I combine K, K combined with L give us M. So the inverse of K is what now? Is L. Inverse of K, inverse of K, inverse of what now? L. What I combine with K to have identity. Please don't forget the definition. Identity is what you combine with something to have what now? That thing back. Then inverse is what you combine with something to have what now? Identity element. So that is that on that. So let us go to what now? To matrices and determinant. 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 We'll go to integration and differentiation. Let us quickly do matrices and determinant first. So under matrices and determinant, we have some questions here. So under matrix, let me quickly introduce you to matrix. If I have something like this, A equals to what now? A, B, C, and D. Okay. This one is called first row. This one is called second row. First column, second column. So it means row is horizontal. Row is horizontal. Horizontal row. And column is vertical. Column is vertical. These are the things that we use under what now? Under matrix. Matrix and determinant. Under matrix. We use rows and what now? And column. So when you remember vice chancellor, BC, vice chancellor, vertical column, horizontal row. So first row, first column. So which element is found in the first row? We have R1, C1, R1, C1. First row, first column. Element what? Element A. First row, first column. This element. Where they intersect. So which element is found in second row, first column? Second row, first column. Where second row, first column? Second row, first column. Element what now? Element C. So first row, second column. R1, first row. C2, second column. R1, first row, second column. How about now? B. Look at this. R1, first row, second column. When it intersect this. Then R2, C2, R2, C2, second row, second column. Second row, second column. It means what now? D. What's that? What's that? So look at this first one. We now have what we call determinant. Determinant. But before I do that, let me just see how we can add. Is it possible for us? Yeah, we can add, we can subtract. You can add element and subtract element if they are of the same dimension. You can add them if they are of the same dimension. Without wasting much of our time. Let me write this one out. Okay. Set P is what? P equals 5, 3, 2, 1. This is 2 by 2. This is 2 by 2. 2 by 2. Meaning row before column. If I want to name a matrix, I will name the row before the column. Okay? 2 row, 2 column. If I have 1, 2, 3, 4, 5, 6. What's the name of this matrix? Row 1, row 2, row 3, column 1, column 2. So this one is 3 by 2. I will call the row first before the column. Either write like this 3 by 2 or 3 by 2. Okay? So the row first before the column. This is 2 by 2. And another element Q. Q equals 4, 2, 3, 5. One has to find 2P plus Q. 2p plus q. Now class, you can add elements if they have the same dimension or if they have the same order. This is 2 by 2. I can add 2 by 2 to 2 by 2. But here I'm having 2p. 2 times p, actually 2. P is what? 5, 3, 2, 1. Then plus q is what? 4, 2, 3, 5. See it? So multiply this one by this. This is 10. 6. This by this. 4. This by this. I have 2. So I'm having this 2p. Then plus what? 4, 2, 3, 5. That's all. Since they're the same thing, 2 by 2, order 2 by 2, or 2 by 2, I can add them. This is 2 times 10, 6, 4. So we have 10 plus this, 14. 6 plus this, 8. 4 plus this, 7. 2 plus this, 7. That's our answer. This is how to add. You can only add the matrices if they have the same order. You can add them. If they, why you add this one? Because this is 2 by 2. This is 2 by 2. They are of the same what? Order. That was the reason why I added them. Because they have the same order. If they are not of the same order, I can't add them. Please don't try it. Don't even dare. Don't dare. So this is this. So now go to okay. How do you multiply matrix? This is the same thing for. So if you put minus here, you just say 10 minus 4, 6 minus 2. Okay, so it's as simple as that. Let me see. Okay, let me see these two questions. Let me see these two questions. So under determinant of the matrix, determinant of the matrix. That's to find determinant. They use this symbol. If A is a matrix, determinant of the matrix. So if A is a matrix, if A is a matrix, okay, its determinant has the symbol like this. So anytime you see double line, I now have something in between the line. Under matrix, that is called determinant. So this is the symbol for determinant. Okay, so let's assume A is what? A is equal to what now? A, B, C, and what? And D. If I'm asked to find determinant of A, look at this. Determinant of A is written like this. What will I do? I'll multiply these two together. A times Z. A times Z minus B times C. B times C. So how will that be what now? AD minus BC. That's determinant of the 2 by 2 matrix. Okay? Element from the upper left to the lower right, we call them leading diagonal elements. Leading diagonal. Or we call it principal diagonal. Principal diagonal element. Okay? So from this upper left to the lower right. So we're doing this one first. We're going to multiply the principal diagonal elements first. Okay? The minus non-principal diagonal elements. So it's as simple as. So this is what we call determinant of a 2 by 2 matrix. This is a 2 by 2 matrix. So determinant of a 2 by 2 matrix. So let me write this one off. So I can solve question. Sharp. So I'm going to how many things to do in this video. So look at this. It says if 5, 3, x, 2 equals 3, 5, 4, 5. Find x. Find the value of x. Find the value of x. Options we have 3, 4, 5, and 7. A, B, C, D. So what's the name of this? I told you, determinant. See it? Determinant. Just to confuse students, they won't say the name. But this thing means what? Determinant. So, leading diagonal element, 5 times 2. So I have 5 times 2 minus 3 times x for x times 3. So I have 3 times x is equals to determinant 2. You see it? 3 times 5 minus 4 times 5. What do I have here? 10 minus 3x is equals to 15 minus 20. So what do I have here? 10 minus 3x is equals to 15 minus 20 is what? Minus 5. What's the next thing? So I can come here to become plus. So I'm having 10 plus 5 equals to what now? 3x. This 15 is equals to what now? 3x. So what will I do? By 3? By 3. You see, you cancel out this 3. Here 1 now? 5. So our x is equals to what now? 5. Option what? Option C. Our x is 5. Question under determinants. Determinants. Okay? So anyhow they want to give it to you, the same thing. Look at another one. Said x 3 2 7 determinant. They didn't say see, they did not say anything. They were silent, but they gave you what now? The symbol. And I've explained the symbol to you. Say our answer is what now? 15. And I have to find what are you going to do? 7 times this, that will be 7 times x, 7x minus 2 times 3, that is 6, equals to what now? 15. So what's the next thing? 7x equals to what now? 15 plus what? Plus 6. So 7s equals to what now? 21. What do we have our x? By 7? By 7. S equals to what now? 3. So what is that under determinant of a matrix? Determinant of a matrix. How do we multiply a matrix? After the multiplication, I'm now going to what we call inverse of the matrix. And that will be all. I'm going to inverse of the matrix. You know how to add. But how do you multiply? We know how to add. We know how to subtract. You can add matrices or subtract matrices if they are of the same order. Meaning I can add 3 by 3 to 3 by 3, or I can subtract 3 by 3 from 3 by 3. They must be of the same order. If not, don't try to. But how do you multiply matrix? How do you multiply matrix? From there, we need to solve question. How do you multiply matrix? Be careful here. Be very, very careful. If I want to multiply matrix, look at this. This is the rule. This is the rule for matrix multiplication. For matrix multiplication, okay. For matrix multiplication, number of column of the first matrix must equal to what now? Number of rows of the second matrix. This is the rule. You want to multiply. You want to multiply matrices together. So if I have something like this, 1, 2, 2, 1, multiplied by 3, 1, 1, 4. Can I multiply this? Yes. See the rule. This one is 2 by 2. 2 by 2. So this is what now? 2 by 2. And what is the rule? Number of column of the first matrix. This is row and column. Abi? Our column is 2. Must just what now? Number of rows of second matrix. Our row is what now? Is 2. So I can multiply. But if I have something like this, 1, 2, 2, 1. And I have 3, 1, 4, 1, 7, 6. Can I multiply this? Let us see. This one is what? What's the order? 2 by 2. What's the order of this matrix? 2 by 3. See? First row, second row. First column, second column, third column. So this one is 2 by 3. And what's the rule? Number of column of the first one. Row, column, 2. But also what now? Number of rows of the second matrix. Row, column. So I can multiply these two. So the first one is always row, second one is what now? It's column. First one is row, second one is what now? It's column. Okay? So look at this. Number of column of the first one multiplies what now? Number of rows of the what? Second matrix. If that is the case, we can multiply. Okay? So that's the first thing that you must know. Before you can multiply matrix, we have rules which I've written out for you. Then here, how do we now multiply? Be careful here. Be very, very careful in this place. Matrix multiplication, you have to be very, very careful. Are you with me now? It is technical but simple. Believe me, it's simple. So how do we do that? I'll take this first one by this first one. Look at this. It will be something like this, something like 7, or something like this. Take this pattern. So it will be this and this. So it will now be 1 times 3, 1 times 3 plus 2 times, I want to form 7, 7, 2 times 1. So I'm done with this one and this. Okay? I'm now going to this one and this. Are you with me? First row multiplied by what now? First column. First row, second column. So I'll leave a space here. So now be 1 times 1 plus 2 times 4. Then I'm done with this and this. I'm now going to the second one. Second row, first column. So that will be 2 times 3, 2 times 3 plus 1 times 1, 1 times 1. I'll leave a space. 2 times 1, 2 times 1 plus 1 times 4. So that is that. That will apply a matrix. So this will now be 3 plus 2, 6 plus 1, 1 plus 8, 2 plus 4. 3 times 1 times 3, 3, 2, 6, 1, 1, 8, 2, and 4. So what's the final result? 5, 9, 7, and 6. That's how we multiply a matrix. That is how to multiply a matrix. So form something like what now? 7, something like this. So first row by the first column, first row by second column, second row by the first column, second row by second column. That's how to multiply. After we've confirmed that it is very possible to multiply. So look at this question. Look at this question. Look at this question. Time some off. This question. Look at this question. Said, okay, 5, 6, 5, 2, minus 6, minus 7, brackets s by y is equals to 7 minus 11. Find y. We have to find y. Find y. Look at the options given: A, B, C, and D. We have 8, 5, 3, and 2. 8, 5, 3, and 2. So let us go, class. Can you multiply this one? Let us see. This one is 2 by 2 now. 2 by 2. This one is 2 by 1. First row, second row. You see it? Then just one column. One vertical standing, that is column, vertical. 1 or 2 horizontal. 2 by 2. So is it possible? The number of column of the first one is equal to the number of what? Rows of the second one. So we can multiply. How do you multiply? We now say 5 times x, 5x, minus 6. You know, say first row, first column. I think you know that. So minus 6 times what now? Y. So minus 6 what now? Y. We are done with that. And this one again, this and this. 2 times x, 2x, minus 7 times y, minus 7y is equals to 7 minus 7. This is what we call simultaneous what now? Equation. So that's equation. So we have to find what? Y. So we must eliminate what? X. So we make sure that what now? Coefficient of x are the same. So this one will be times what now? 2 times what now? 5. So we can have 10x minus 12y, 14. 10x minus 35y equals to minus 55. Now subtract. Simultaneous equation, elimination method, elimination method. This and this is 0. Having minus 12 minus 12y minus 35y. Minus 12y minus 35y. That will be minus 12y plus what? 35 what now? Y. So what is 35 minus 12? That will give us what now? 20. This is 3. This is 2. 23. 23. Yes, this is 23. 23y is equals to. So here we're having 14 minus 55. So 14 minus 55. That will be 14 plus 55. And that will give us what now? 69. 69. So ordinary y by 23 by 23. So 23 will cancel out 23. Y will just what now? 3. Yes, 3. So 69 divided by, I put 3 here. 3 times 3, 9. 3 times 2, 6. So our answer is what now? Our answer is 3. That is that on that. So let us go to what? Inverse. Inverse of an element. So we can go to indices and what now? And indices and what's that? Sorry, integration and differentiation. Integration and differentiation. So that is the next thing. So then we're going to go to our solve. If time permits, go to solve. Go to solve because we have plenty of things to solve here. I'll be very fast, but we are going to get it. We are going to get it. So that is that under matrix. We've done determinant, and again, whenever you see I under matrix, that I means what now? Identity what matrix or unity matrix. So when you see symbol I, you will say where I is a 2 by 2 identity matrix. Okay, what meaning of I identity matrix? So I equals to what? If it's 2 by 2 to be 1 0 0 1. It's constant. If it's 2 by 2, but if it's 3 by 3 to be 1 0 0 0 1 0 0 0 1. What's the meaning? Leading diagonal element. The leading diagonal, principal diagonal will be 1. The others will be equal to what now? 0. That's the meaning of identity element. This one is 2 by 2. 2 by 2 identity element. Identity matrix. And this one is what now? 3 by 3 identity matrix. So in the question, they can say A equals to maybe 2 1 1 2. Okay, now say you find A plus 2I. Now say where I is a 2 by 2 identity what now? Matrix. Are you with me? So in that case, what are you going to do? A plus 2I. What is I? They did not give you. But we know that it's a constant. 1 0 0 1. Okay? So I'll put that here. So this will now become what? So our A plus 2I. So A plus 2I will now be equal to what now? A 2 1 1 2 plus 2 brackets. Since they say I is what? 2 by 2 identity matrix. What's the constant? 1 0 0 1. So that will now be 2 1 1 2 plus 2 times 1 2 2 times 0 0 2 times 0 0 2 times 1 2. Can I add them? Yes. 2 plus 2 4 1 plus 0 1 1 plus 0 1 2 plus 2 are 4. So what is that? Is it clear? So if they say I, I've explained that too. I means what now? Identity or unit matrix. Unit matrix. So they can ask you that in the question. They can give you that in the question. Okay? So then we are moving forward. Yes. We'll get there because this is our year. And you can stop that. Please subscribe. Please help this channel to grow. We want to reach that what now? 1K subscribers. Okay, 1K subscribers what now? Milestone. As at the time of recording this video, we have 500 plus. We want to reach 1K. For the 1K, we want to shoot it up to what now? To 100K subscribers. With your help, please always share our videos. Comment, like, subscribe. Please continue to share the videos. All our videos, New Teacher School. Our YouTube channel, New Teacher School. New Teacher. When you go New Teacher School, you see all our videos. They help us to do more. We want to reach the 1K. For now, let us reach 1K. Then after the 1K, we want to talk to what now? To 100K subscribers, which is very possible. Which is very possible. I know it is very possible. Very, very possible. If you can just subscribe and share the links. Okay, share the links to all our videos. And anything you want, let us know in the comment section below. I want this so topic. I want so topic. Okay, so we are here for you, and we are going to get there together. So give this video a thumbs up. Just press that icon like this. Press it. Subscribe. Comment in the comment section below, and share the links. So let us continue. So whenever you hear inverse of a matrix, what they will give is just 2 by 2. Highest they will give is 2 by 2. Highest they will give is 2 by 2. Are you with me? Inverse of a matrix. Inverse of a matrix equals to what now? Adjoint of that matrix. Adjoint of the matrix. So what inverse of a matrix A to be adjoint of A all over determinant of A. Determinant of A. Okay? Whenever you multiply a matrix by its inverse, you must have what? Identity element. So if I say A multiplied by A inverse, it must give me what now? This is a what? This is a fact on the matrix. Whenever I multiply a matrix by its inverse, it must give us what now? Identity element. Identity element. And which we know, either 2 by 2 or 3 by 3. But this is the formula for what? Inverse of the matrix. Adjoint of that matrix all over what now? Determinant of that matrix. But in the exam, they give us 2 by 2. For now in JAMB, 2 by 2. So instead of wasting our time, because for this adjoint, you must first get minor. You get minor. You get cofactor. Before you now get what now? Adjoint. So minor, cofactor, and adjoint. So this one is wasting of time. If it's 2 by 2 matrix. So if you say A equals, okay, let me just solve the question direct so I will not waste time. Find the inverse of this matrix 5, 3, 6, 4. Okay, so I'll give us the options. Say A2 minus 3 minus 3 over 2, 5 over 2, that's A, then B, 2, three over 2 minus 3 minus 5 over 2, C, 2, 3 over 2 minus 3 minus 3 over 2 minus 3 minus 5 over 2, and this is minus 2, this is minus 2, 3, 5 over 3 over 2 minus 5 over 2, minus 2 minus 3. Alright, so and then we have to find what now? Inverse of a matrix if it is 2 by 2 in the exam. We know that inverse is what? Adjoint of what? Adjoint over what? Over determinant. The first thing is, let us get determinant first. Okay? So what is determinant? Determinant will be equal to what now? 20 minus what now? 18. I think you know that. 5 times 4, 20. Minus 3 times 6, 18. So our determinant is what? Is 2. Determinant is 2. Determinant is 2. Abi? Determinant is 2. So we'll keep this one first. So how do you now get adjoint? I want to give you the shortcut for adjoint. What are you going to do? Just interchange. You interchange the leading diagonal element. Interchange the leading diagonal element. And the non-leading diagonal element, you give them minus and minus. What's up? That's all. So what am I saying? Look at this. Let me interchange. So if you want to interchange, what is the rule? Interchange leading diagonal element. Okay? Then introduce negative signs to the non-leading diagonal element. That's all. So before you put down the what now? All over the what? The determinant. Look at this. So where is the element given? This is matrix. Where is the leading diagonal element? 5 and 4. I will interchange them. So it means 4 will come here. 5 will come here. I will now introduce negative sign to the non-leading diagonal element. This will be -3 -6. That's all. Then all over determinant. Okay, because we say all over, determinant is what now? Is 2. So it's same as saying 1 over 2. Are you with me now? 1 over 2. So this will now give us, how do you get what I'm saying? Under inverse of a 2 by 2 matrix, which is the highest one they can give you in JAMB, just interchange the leading diagonal element. 5, this is the leading diagonal element. What are the leading diagonal elements? Element from the upper left to the what now? Lower right. I will interchange them. 4 will go here, 5 will come here. And that's what I've done here. 4 comes up, 5 goes down. I've now introduced minus here. Minus. But if this one was initially minus, it will be plus now. When I introduce minus, it will be plus now. But thank God it was not what now? It was not minus, it is plus. So this will be minus. See? You maintain these ones, you maintain them. You just put minus here, minus here. Okay? If this one was minus before, when I introduce minus, it will become plus. I hope you get that. So please take note too. So what's now the next thing? Half times 4, that will be 2. Half times minus 6, minus 3. Half times minus 3, minus 3 over 2. Half times 5 over 2. So the answer to that question is what? Is A. So that's how we do inverse of a matrix. Inverse of a matrix. That's how to solve question under what now? Inverse of a matrix. So let us go to differentiation and integration. Differentiation and integration. So what is that? Let me turn this one off. So you can just pause the video and see the way I solve this question. Let me turn this one off. Under differentiation and integration, you have to note this. Note this. We have to differentiate. We have to differentiate. Differentiation. And this is what now? Integration. Integration is opposite of what now? Differentiation. For differentiation, what's the general rule? If y is equal to what now? X is power n. Y is a function of x. So here, dy dx will be equals to x is power what now? n minus 1. Or if I have a here, a, which is the coefficient, I'll first use this power to multiply this a. I'll have a times n, an. I'll write this s back. X is power what now? n minus 1 under differentiation. But for integration, the integral of x is power n dx. This symbol is integral sign. Integral of x is power n dx will be x raised to power n plus 1 all over n plus 1 then plus c. Some use c, some use k. Where c is what we call arbitrary constant of integration. Constant of integration. So this one here, this one is indefinite. Indefinite integral. We are still coming to what now? Definite integral. I'll tell you when we get them. So it means if I have something like this, the integral of x is power 3 will be equal to x is power 3 plus 1 all over 3 plus 1 then plus c. That will now be what? X is power 4 all over 4 plus c. It's as simple as that. As simple as that. Our n is what? Is 3. I will add 1 to it. But if I have y is equals to what now? X is power 3. What is dy dx? This will be, here is 1. I'll say 1 times 3. I'll write x back. I'll now subtract what? 1 from this one. Under integration, I'm adding 1. Under differentiation, I'm subtracting 1. This should not be what now? 3 x raised to power what now? This power 2. 3x raised to power 2. Okay? Are you with me? So this does general rule of what? Of differentiation and general rule of what now? Integration. So let us go. We'll be done very soon. Please bear with me. We have many rules. Just please, I have differentiation video on this channel. You can just go and watch that. I'll put the link of that video in the comment box below. Okay, I'll put the link of that video. Calculus video. I think I put calculus 1. Comment that. Just go and check the video. Okay, so I explained virtually everything that you need to know under integration, under differentiation. I put limits there, and I put what now? Differentiation. Differentiation. So go and watch the video so you have more in-depth knowledge under differentiation. Under differentiation. So look at this. The first one, we have to differentiate. Let me see. Okay. Y equals to 4x cubed plus 2x squared minus 5x plus 7. So what is the y dx? The y dx will be equals to this 1 by 1. You use the rule. 4 times 3, 12. That is power 3 minus 1, 2. I'm using the general rule. 2 times 2, 4. That is power 2 minus 1. That is 1. Minus. This one is 1. 1 times minus 5 minus 5. Then 1 minus 1 is what? Is 0. Let me just write it out for those I want to get the concept very well. 4 times 3. 3 minus 1. 2 times 2. 2 minus 1. 5 times 1. 1 minus 1. Plus. When you have to differentiate a constant, it will be 0. 0 is a constant. Even if I put minus 7 there, it's still a constant. It will give us 0. Okay? Anytime I have to differentiate a constant, answer is 0. So this one will give us what now? 12 x to the power 2 plus 4x to the power 1 plus what now? 5. How did I get 5? Because 1 minus 1 is 0. X to the power 0 is what now? Is 1. So this is what now? This is the answer. This is the answer of that question. This is the answer. We now have many what now? Many rules. Like I told you, go and watch the video. Go and watch the video under what now? Under differentiation. We have many rules there. But yeah, I'll just be solving the question. Look at this. We have to, if y equals to what now? If y equals to 2x plus 1 raised to the power 3, find the y dx. Find the y dx. Find the y dx. This one is what now? What we call chain rule. Chain rule of differentiation. Chain rule of differentiation. So we'll call it what now? Function of function. Function of function. Function of function. Or chain rule of differentiation. So how do you do that? Anytime we are given what now? This. If I have y equals to what? Ax plus b raised to the power n. Anytime we see a question like this, how do you differentiate? Our dy dx will bring this power down. Our n will bring it down. See n times. I'm switching the shortcut. We differentiate what I have here. Differentiate ax plus b. Differentiate ax plus b. That's what I have inside. Okay. Then times. I'll write this thing back. Ax plus b. I'll now subtract 1 from the power. This power what now? N minus 1. Let me write it so you're able to see it very well. Anytime I have to differentiate the question in this format, so our dy dx because I'll bring this power down n times I'll differentiate what I have inside here. I will differentiate ax plus b. I will write it back. Ax plus b. I'll now subtract 1 from this power. That is the rule. That's the shortcut. So what happened? So increase our dy dx here. Because to bring 3 down, 3 times. Differentiate 2x plus 1. How we also 2. From general rule. This is 1. 1 times 3 is 2. X to the power 1 minus 1 is 0. X to the power 0 is 1. So this one will give us what now? If I'm asked to differentiate 2x plus 1 to give us 2, then times, I'll write this thing back. 2x plus 1. I'll now subtract 1 from here. 3 minus 1. This will now be 6 bracket what now? 2x plus 1 is power 1 2. And the options we have A, 6 bracket 2x plus 1 is power 2. B, C bracket 2x plus 1, C, 3 bracket 2x plus 1, x power 2, then D, 3 bracket 2x plus 1 plus 1. So the answer is what now? Is A. 6 bracket what now? 2x plus 1. Using this formula. So just write the formula down. So anytime you see question like this, under the position, use this shortcut. So that's the type of that. Now, let me give you some facts under what now? Differentiation and integration. So I'm going to be doing that. Look at this. Now, if I see d dx, pay attention. This is differentiation. This is integration. If I'm asked to differentiate d dx, meaning differentiate sin x, our answer will be what? Cos x. If I'm asked to differentiate sin x, our answer will be cos x. If I'm asked to integrate cos x dx, our answer will be what now? Sin x plus c, or sin x plus k. Okay? We said integration is the opposite of differentiation. So if I'm asked to differentiate sin x, I'll have this d dx means differentiate. So sin x, I'll have cos x. So what's the opposite? I will now integrate cos x. I will have what now? Sin x plus c. If I'm asked to differentiate cos x, I will have minus sin x. If I'm now asked to integrate sin x dx, I will have minus cos x plus c. If I'm asked to differentiate tan x, our answer will be equal to sec square x. So if I'm asked to integrate sec square x dx, our answer will be what now? Tan x plus c. If I'm asked to differentiate sec x, okay, our answer will be sec x tan x. So if I'm asked to integrate sec x tan x dx, I think you are getting the format now, the pattern. To give us what now? Sec x plus c. You're going to see the integration of all these. If I'm asked to differentiate cosec x, our answer will be minus cosec x cot x. So if I'm asked to integrate cosec x cot x dx, our answer will be equal to minus cosec x plus c. If I'm asked to differentiate cot x, our answer will be minus cosec square x. So if I asked to integrate cosec square x dx, our answer will be minus cot x plus c. If I'm asked to differentiate then x, our answer will be equal to what? 1 over x. Then means what now? Logarithm of a number to base e. Of a number to base e is what we call ln x. Ln. So logarithm of a number to base e is ln. So when I ask to differentiate ln x, I will have 1 over x. But if I'm asked to integrate 1 over x dx to be ln x plus c. Please be mindful of what this I'm writing. If I'm asked to differentiate e raised to power x, our answer will be what now? E raised to power x. So it means if I'm asked to integrate e raised to power x dx, I'll have e raised to power x plus what? Plus c. E raised to power x plus c. Okay? So that is that. Any other thing? I think we are good like this. But if I have sin ax, it will be a cos ax. If I have differentiate sin ax, it's not having a constant. Answer will be a cos ax. A cos ax. So it means I'll differentiate as first to give us a times. But if I have it like this here, integrate sin ax dx. Our answer will be 1 over a. Look at this one. When we have to integrate sin x, we have minus. So I'm going to have in minus 1 over a, then cos ax plus c. Cos ax plus c. But if it's what do you call it? If it's differentiation, like I told you, go and watch the video under differentiation. I've done that. Watch the video. I'll put the link down. Just watch the video. Take time to watch the video. Under what? Under differentiation. I've done the video. So these are the what now? Standard what now? Standard format or pattern under differentiation and integration. So I'm going to solve question now based on what I have here. Based on what I have here. But I have to find the derivative. Let me clean some parts here. Let me clean some parts here. Let me clean some parts here. But I have to find the derivative of, meaning find differentiate. Find derivative of sin theta over cos theta. I'm given the options A, sec square theta, B, cosec theta, sec theta, C, cosec square theta, D, tan theta, cosec theta. So what are you going to do here? If you remember our basic identity, the first one is tan something is equals to tan of something is equals to what now? Sine of that thing. So tan x is equals to what now? Sin x over what now? Over cos x. So invariably, we have to differentiate what now? Tan theta. You understand? Because tan theta is standard sin theta over cos theta. So we have to differentiate what now? Differentiate tan theta. Just to maneuver, make us to think. So this one has to differentiate what now? So when I differentiate tan theta, what will I get? Sine square what now? What's that? From the derivative I gave you. I've cleaned it up. So our answer is what now? So we don't need to do anything here. Just by knowing the concept, so it's out. Differentiate tan theta. Our answer is what now? Sine square theta. Sine square theta. That is that on that. So I'm combining everything. Differentiation and integration. Combining questions from there. Right? So if y equals to s sin x, find the y dx. Y equals to what now? X sin x. We have to find the y dx. Find the y dx. We have to differentiate. So what do? So is what we call product rule. So it means our u equals to x, our v equals to what now? Sin x. I will differentiate this one. The u dx give us what? 1. The v dx give us what now? Cos x. When you differentiate sin x, we have cos x. So what's now our y dx? Product rule. We have u dv dx plus v du dx. Product rule. So what does this one give us? It's very simple. Whenever I have something times something to differentiate, I'll use this rule. As simple as that. So I will keep my u constant. I use x times what is the derivative of v? Cos x plus keep my v constant sin x times what is the derivative of u? 1. The answer here goes to what now? S cos x plus what? Plus sin x. S cos x plus sin x. Just go and watch the video. You learn more on that. Let me see. Okay. Okay. Under the application, yes, under the application of differentiation. Under the applications of what now? Differentiation. Look at this. Application of differentiation, we have applications of differentiation, application, differentiation, differentiation. We have gradient of the curve, gradient of the curve at a point, we have turning point. This turning point can either be what now? Maximum or minimum, maximum or minimum point. We have rate of change, or we call kinematics. So I'll solve question on this. But yeah, I'm seeing one here now. I'm seeing one under what now? Under applications of what? Said at what value of x does the function? At what value of x? At what value of x does the function? The function. What's the function? Are given y equals to what now? Minus 3 minus 2x plus x squared attain a minimum. You see that? Minimum value. A are given 4, B 1, C plus 1, and this what now is 4. This is one of the applications of what? Of differentiation. One of the applications of differentiation. Minimum points. You see, turning point. Maximum or minimum. At turning point, what happened? At turning point, the y the s must go to 0. Take note of that. At turning point, either minimum or maximum. At turning point, our dy over the s goes to what now? 0. So it means we're going to differentiate this one, and our answer will equate to 0. That's all. So what are we having here? Our dy dx, because this is a constant, is 0. When you differentiate this one, you have what? Minus 2 plus 2x. General rule of differentiation. When you differentiate this one, you have minus 2 plus 2x. So at turning point, what happened? Our dy dx at turning point, like I told you, dy dx equals to what now? 0. So it means our what? Minus 2 plus 2x equals to what? 0. So what happened? Correct like terms, 2x equals to what now? 2 by 2 by 2. So that's how this, our s equals to what now? 1. So the answer is what? Is B. So whether you are given minimum points or maximum points, at turning point, this turning point is what now? Minimum or maximum? Our answer must be equal to what now? 0. When you solve, you must have answer to be equal to what now? Is 0. Answer to be equal to what now? Is 0. So I think since I have the original question, okay, just go and watch the video. I'll put the link down. So let us solve more questions under what now? Under integration. Then under application 2, if they say you find the what? The gradient of the curve. Find the gradient of the curve. Find the gradient of the curve. Y equals to what now? 2x squared plus 4x plus 1 at, you can say x equals to what? 1 at x equals to 1. Or they go and put 1 comma what now? 1 comma 2. This is for x, this is for y. At 1 comma 2. We don't need this y. What we need is just what now? Point of x. Either they say at x equals to 2 or x equals to 1, or they say at 1 comma 2. I don't need this y. I need point x. Okay, so what's the first thing? I'll first differentiate. The y dx is what now? Gradient. That will be what? 4x plus what? Plus 4. Then x equals to what? 1. That will have the 4 bracket what? 1 plus 4. What is this? 4 plus 4. That will be what now? 8. So the gradient of this curve at point x equals to 1 is 8. If they put 2 here, anywhere I see s, I'll put 2. If they put 0, if they put minus 1, everywhere I see s, I'll put what? Minus 1. It's as simple as that. So let's go to one question under one, integration. This video is becoming too long. Becoming too long now. Becoming too long. Becoming too long. Alright, so let's quickly solve. So next video we'll do solve and another thing. So let's stop here. Let's quickly solve question under integration. So let's integrate 1 over x plus x with respect to x, with respect to x. So it means I'm going to integrate 1 over x plus x, that's the meaning, then dx. I'll now use one by one. I'll open this bracket to be integral of 1 over x dx plus the integral of cos x dx. Class, if I have to integrate 1 over x, what's our answer? In x. So I'm having in x plus, if I want to integrate cos x, what's our answer? Sin x. So sin x plus c. And if you check the options, we are given a 1 over x squared plus sin x plus k, b then x plus sin x plus k, c then x minus sin x plus k, then d 1 over x squared minus sin x plus k. So I can change this one to what now? To plus k. I told you that is what now? K or c. So that's the answer. By virtue of the what? This standard what now are integration. So you must know all these. You must know all these. So that is that with that. Integrate tan square x. Integrate tan square x. Tan square x. Tan square x. Integrate tan square x. How to integrate? Integrate tan square x. So here, option we are given tan x minus x plus c, b tan square x minus 2x plus c, c x minus tan square x plus c, then d x minus tan x plus c. So what will I do? What will I do? If you check, this one is not inside what now? Inside standard integral. But this one here, from basic identity, check my video under what now? Under trigonometry. I've explained this. Check the video under trigonometry. So here, trigonometry, please. So here, I have tan square x plus 1 must give us what now? Sec square x. From basic identity. Okay? So it means here, if I want to make tan square x separate formula, I have tan square x is just what now? Sec square x minus 1. So it means we have to integrate sec square x minus 1. The what? The x, that's the meaning. But this is our tan square x. Okay? We'll now be having integral of sec square x dx minus integral of what now? 1 dx. When I integrate sin square x, what will I have? I have tan x. And when I integrate 1, I have what now? X. Plus what now? Plus c. If I integrate 1, I have x. So one side is what now? One side is this video is getting longer. It's getting longer. And I don't want to let me quickly explain definite integral. Let me quickly explain definite integral. We are giving question under definite integral. Do you have any question on definite integral here? Any question under the yes, I see one. Alright, so let me have this one off. Definite integral. On definite integral, we have this. Definite. Say integral of what now? A to b, maybe a squared. 2 to 1 of x squared dx. Definite. So a is what now? 2 is the upper limit. Then 1 is what now? Lower limit. So it means I'm going to solve the question first. You now subtract lower limit from upper limit. So if you integrate x squared, you have x raised to power 3 over 3. Ranging from what now? 2 to 1. So when x is 2, what do you have? You have 3 raised to the power 3 over 3 minus when x is 1, you have 1 raised to the power 3 over what? 3. I hope you understand what I'm trying to say here. After you've done your integration, you now put when x is 2, get your value, minus when x is 1, get your value. So this one will be what now? 8 over 3, I suppose. As what now? 1 over what now? 1 over 3. So what's the SCM? 3. So now what now? 8 minus what? 1. This will not be what now? 7 over what now? 3. So this is what we call definite integral. Definite integral. Why? Because it has what now? Limits. Upper limit and lower limit. If question is given in pi is 180 degrees. Pi is 180 degrees. 180 degrees pi. And that will be the last thing I'm going to solve. And I promise in the beginning of the video, I want to give you some bonus. So look at this. Okay. So let's evaluate integral of pi over 2 to 0 of sine x dx. Option A, 2 minus 2, rather B, 2, C, 1, and D minus 1. So what I'm going to do here, you first integrate. What is sine x? Sine x is what now? Minus cos x. Are you with me? So when you integrate sine x, you have what now? Minus cos x. So this one will give us minus cos x, ranging from what now? Like I told you, pi equals to 180 degrees. Pi equals to 180 degrees. So what is pi over 2? That's what now? 90 degrees. So ranging from what now? 90 degrees to what now? To 0. Upper limit, lower limit. Are you with me? So it means anywhere I see s, I'll first put what now? So I'm having minus cos 90 minus cos 0. Be careful here. Our answer is minus cos x. So minus cos upper limit 90 minus then minus cos lower limit is 0. The thing is upper limit minus lower limit. So what is cos 0? Cos 0 is what now? Sorry, cos 90 is what now? Is 0. So I'm having 0 minus. What is cos 0? Cos 0 is what now? Is 1. Cos 0 is what? Sin 90. Sin 90 equals to what now? Cos 0. Okay, which is 1. Sin 90 is 1, cos 0 is what? Is 1. So I'm having minus sin 90 is what? Is 4. So I'm having plus 1. The answer is what now? Is 1. Option 1 from C. Okay, so we can have this one under definite integral. So the bonus that I promised you, because this video is getting longer. So let me just clean this one up. So if you have any question to ask, just call any of the numbers on the screen. And we'll attend to you. Alright, so look at this. So for the bonus, when you have to find undefined expression, they say for what value of x is the function x squared minus 2x plus 4 all over x minus 2 undefined. Either I say undefined or not defined. So for undefined fraction, a fraction is undefined when denominator equals to 0. A fraction is undefined when the denominator equals to 0. I'll just say x minus 2 equals to what now? 0. So what are x? So you see option A, 2, B minus 2, C, 1, D minus 1. A fraction is undefined. A fraction is undefined. Okay? When the denominator equals 0. It means I will just take what? I will take the denominator only. I will equate to what now? To 0. So I'll get my what now? My answer. For undefined fraction, okay? Just to find undefined fraction, I'll just take the denominator, go to 0, and I'll get what? My value of what now? My value of x. Then for perfect square, say perfect square. What must be added to this to make it a perfect square? Okay? What must be added to x squared minus Let's do something like this. 3x squared minus 5x to make it a perfect square. Perfect square. So perfect square. The other one is what now? Is perfect square. Either they say perfect square or they say complete square. Complete square. Complete square. Okay. So this is the formula for complete square. For complete square, what's the formula? B squared must be equal to what now? 4ac. Take note of this. For complete square, B squared must be equal to what now? 4ac. Okay? So that's the formula for what now? For perfect square. Whenever you get what? Perfect square. So what must be added to this to make it a perfect square? So let's say let k be added. So if we're adding k, we're having 3x squared minus 5x plus k. We've added the k. So what's our a here? Our a is what? Our a is 3. Our b is what? Minus 5 with the sign. Minus 5. Our k, our c rather. Our c is what now? Is k. Our c is k. Our a is the coefficient of x squared. Our b is the coefficient of x. Our k is the constant. Our c is the constant. A, coefficient of x squared. B, coefficient of x. C is the constant. So what is now the answer for perfect square? It means what? Our b squared minus 5 all squared is equal to what now? 4 times our a is what? Our a is 3. Our c is what? Our c is k. So what do we have here? 25. Just what now? 12 what? 12k. So what's our k? By 12. By 12. This will cancel out this. So k is also what now? 25 by what? By what? By 12. So it means 25 by 12 must be added to this expression to make it a perfect what now? Square. Whenever you get the word perfect square or complete square, this is the formula. B square must equal to what now? 4ac for perfect square. And the last one is when you are asked to construct a quadratic equation and the roots are given. Okay? You have to construct a quadratic equation and the roots are given. Look at this. Look at this. So please subscribe to our YouTube channel. Okay? Like the video. Share the link. Okay? And comment in the comments section below. So say what is the quadratic equation? What is the quadratic equation? Quadratic equation whose roots are 3 and minus 2. So anytime you have to construct a quadratic equation and the roots are given, how do you solve it? Just say what now? One of the roots is 3. The other one is what now? It's minus 2. So this one will come here. I have s minus 3 bracket. So will come here to become plus s plus 2. That's what now? 0. That's all. I'll now open the bracket. S times x squared. S times plus 2 plus 2x. Minus 3 times s minus 3x. Minus 3 times plus 2 minus 6 equals to what now? 0. So now the s squared minus x minus 6 equals to what now? 0. So this is the quadratic equation. These are the roots. So once you hear write a quadratic equation with given roots, that's solve it. Or use the general formula. S squared minus sum of the roots bracket s plus product of the roots plus what? This is general formula. But I prefer using this. Just make that one s is this, the other s is this. Then you bring this one here. No, it was plus here. When it comes here, it becomes what now? Minus. So it's minus. When it comes here, it becomes what now? Plus. Then it goes to 0 and open the bracket. So thank you very much for watching this video. I'm very grateful for watching this video up to this moment. It means you guys are special. Okay, this is our year, like I told you. Kindly subscribe to YouTube channel, like this video, and comment in the comment section below. Like it, subscribe. and share the video. Help us to do more. We are about reaching 1,000 subscribers YouTube milestone as at the time of recording this video, and we want you to help us to attain this milestone. So God bless you very much for listening. I will see you in the next video. Thank you.